I'm Mr. Craig and I want to talk about writing molecular formulas today. Now remember, when writing molecular formulas, molecular simply means that we have two nonmetals or a nonmetal with another nonmetal. What we will do in this class in honors chemistry is just deal with what's called binary molecular compounds, which means that there's only two different types of nonmetals. But before we do that, let's make sure that we know our Greek prefixes. So let's take a look here. All right, a couple things that we need to recall or remember is that when we are working with molecular compounds, we do not care about charges. And the nice thing is that, again, when we're working with nonmetal, it's a very small portion of the periodic table. I'm not even going to throw the periodic table up here because you should know your 52 elements, names, and symbols. And this is a very, very small fraction of those 52 that we're actually going to be dealing with. We will use, every once in a while, a noble gas. We haven't talked about it formally yet, but a couple of the noble gases that are farther down on the periodic table are very large and can form some compounds. But dealing with the noble gases that are higher up, like the heliums and neons, they do not form any compounds. So don't think that whenever you see a noble gas that, there's a possibility that it could form a compound. That's simply not true. So let's talk about the Greek prefixes. You have to know the Greek prefixes from 1 through 10. So if we look at number 1, obviously we've hopefully heard about mono. 2 is di. So you might be thinking about bi, but bi is not Greek. We're only going with the Greek prefixes. 3 is tri. 4 is tetra. So you may have played the game Tetris before, and hence the name, the 4 blocks, Tetris. 5 is penta. So penta. 6 is hexa. 7, and this is where it gets kind of confusing for some of you when you're first learning hexa, hepta. Between 6 and 7 is hepta. So it has an H-E-P-T-A. They sound very similar, hexa and hepta. 8 is octa, just like in an octopus. So we have octa. 9 is a little strange. It's nano, or nana, however you want to say that. Nano or nana, I would accept. So if you had nano or nana, either one's accepted. I don't have a problem with either one of those. And then 10 is deca. Okay. So those are as high as we go. So make sure that you know those 10 Greek prefixes. I probably most often will be using the nano more than the nana. So let's go ahead and just say that it's going to be nano. Okay. So nano is 9 when we look at that. All right, so let's take a look at some practice problems, and I will, for this video, work out the evens. So let's take a look at those. All right, so again, let's take a look at the evens. And again, whenever we're naming the nonmetals on the first nonmetal, it is what it is. And if we need to put a Greek prefix on there, we'll attach it at the beginning. But we don't drop the last syllable or last 2 syllables on the first nonmetal. We only do that on the second nonmetal. And so we will be changing all of the nonmetals to an "ide" for what we're doing with these molecular compounds. Also recall that if you only have one kind of nonmetal, in other words, there's only one of those, we do not use the Greek prefix mono on the first element. But you can use all the Greek prefixes on the other ones. If you only have one of the second element, you must use mono. So we still use the Greek prefixes on all of the elements, except on the first one, if there's only one, you don't say mono. So we do have Si, which is silicon. Okay, so we don't call that monosilicon, it's just silicon. And then we have oxygen, so again, drop the YGN and call that an oxide. But since there's 2 of those, we'll call that dioxide. And I will hyphenate until you guys get comfortable, so you don't have to worry about, well, do I drop a letter or whatnot? it's up to you. So hyphenating, there's nothing wrong with hyphenating. I highly encourage hyphenating at the beginning here. All right, so SiO2 is silicon dioxide. Let's take a look at number 4. Here we do have more than one of the first element, so we have to use a Greek prefix. So again, if we had 2, that represents di. And the sulfur, so it's disulfur. Again, we are not dropping the last syllable and adding IDE. We have nitrogen, so change nitrogen to nitride. However, since we have a 4 there, we're going to call that tetra nitride. Okay? So disulfur tetranitride. And again, if you don't want to hyphenate, that's okay with me. I will do that just for the first couple times. Looking at number 6, we only have one type of element, so we don't use mono for that. So it's not mono boron, it's just boron. So boron, and we do have iodine. So we drop the last INE and add ide, so we have iodide, but since there's 3 of those, we'll say that's triiodide. Okay. So triiodide. Not too bad, is it? Try the next couple on your own. Pause the video and write these names out without taking a peek here. Now, hopefully you recognize the CO2. That's one of our waste products. Carbon. So again, do not say it's monocarbon, but the oxygen, we do have 2. So that's a dioxide. So carbon dioxide. Let's go to the top on the other side. Okay. And looking at number 10, so we do have more than one of the first one, so it's a tri for the 3. And we don't do anything to the name, so it's trinitrogen, and we have 6 oxygens. Now here's a good stopping point to talk about. Notice how these are not simplified. Only ionic compounds have the subscript simplified. When we look at molecular compounds, some of these things could have huge numbers and could be simplified, but we never do that. Later on, we'll talk about empirical formulas, molecular formulas. We're not talking about it right now. So don't freak out and go, ooh, that could be reduced down both 3 and can go into both 3 and 6 to make that a N1O2. We're not doing that. This is what that compound is. So we don't have to worry about reducing those values down. Not with molecular compounds. With ionic, yes, but we're not doing any ionic stuff for a while here. So 6 is hexa, and the oxygen is oxide. So in this case, trinitrogen, hexaoxide. Okay. And once you learn the Greek prefixes, again, this will get so much easier because there aren't as many nonmetals and there's only 10 Greek prefixes. So we do have phosphorus, and we do have a 4 there, so a tetra. So tetraphosphorus. Okay, so tetraphosphorus, and then we have an 8, which is an octa. And we have an oxygen, so an oxide. Okay. So tetraphosphorus, octa, oxide. Okay. All right. Number 14, we only have 1 nitrogen, so we don't need to do anything to that. So it's just nitrogen, not mono. And we do have 2 oxygens, so we've got a di here. And the oxygen goes to oxide. So nitrogen dioxide. 16, the last one here. Looks like we have 1 xenon, and that is a noble gas, so make sure you still know your noble gases. So xenon, and it's not a mono xenon. We have 4 fluorines, so we have a tetra. fluorine fluoride. Okay. All right, not too bad. And I think this is probably a little more involved than what we're going to do here next with the changing the names into the formula. So this might be a little easier. And again, you may notice that I did hyphenate these. If you don't want to hyphenate them, that's fine. In this case, there would only be one oxygen, or I'm sorry, one O in the monoxide. So, and that's where some of you might be saying, well, how many? When do we drop certain letters? Like in the pentaoxide, that A would not be there. But if you're hyphenating, hey, it makes it a lot easier. Right, so let's take a look at these. And again, it might be a little easier going from the name to the formula. So let's take a look at the evens, and I think this one's numbered a little bit differently here. So it looks like all the evens are on the right-hand side. So iodine trichloride. Notice that there is no Greek prefix in front of the iodine, so we can simply state that we have just an iodine and that there's one of those. Trichloride, we have a 3, so chlorine, Cl3. So iodine trichloride looks like ICl3. Remember, if I'm going to make an I, it looks like that. This is not a carbon, or I'm sorry, this is not a carbon with an iodine. Okay? And I'll work very, very hard to make sure that the I is capitalized and looks like an I beam, so to speak. All right, number 4, nitrogen triiodide. So again, notice no Greek prefix in front of the nitrogen. So we have a nitrogen, just one of those. Triiodide means that we have 3 iodines. There you go. Silicon dioxide. So silicon, not one that we use very often, but make sure you still know it. Silicon is Si. The oxide means that we have an oxygen. The di means that we actually have 2 of those. Carbon tetrabromide. So no Greek prefix in front of the carbon, so just a C. We have 4 of these bromines because we have the tetra. So CBr4. Tricarbon, here we go. So we've got a carbon. It says that we have 3 of those. Hexahydrogen, so we have a hydrogen. And the hexa means that we have 6. Again, we are not simplifying these values here, so do not do that. Tetrasulfur heptaoxide, so again the sulfur. Tetra means that we have 4. Oxide, and the hepta is 7. Okay, hexa is 6, hepta is 7. Looking at dichlorine, so we have a chlorine, and di means that we have 2 of those. Monoxide, only 1 oxygen. Radon. Radon 152, it's actually the biggest noble gas that we currently have. So radon is Rn. Hexabromide, so we have 6 of those. Hexa is 6. And then tetranitrogen, so we have a nitrogen. And tetra means that we have 4 of those. Octaoxide, so N4O8. Again, these molecular compounds are not very difficult. The hardest part is memorizing the 10 Greek prefixes and making sure that you know the names and the symbols. Hope this video was helpful.